I'm Devin. I'm a junior at Olin College of Engineering, and I'm majoring in mechanical engineering. I'm also, on the side, doing research in the Olin Intelligence Vehicles Lab, working on mechanical design for multi-copters. Olin College and Ocean Alliance partnered to create the SnotBot project, which centered around using multi-copters to non-invasively get tissue samples from whales that would otherwise be harmful for the animal and difficult to obtain.
My name is Andrew Bennett. I'm a professor of robotics and systems at Olin College of Engineering, and I came to Olin from industry, where I spent many years as the head of research for iRobot Corporation. The original landing gear we had were traditional carbon composite layups, and they all shattered on landing. We went through all of our spare parts fairly quickly. So we needed something that had more give, more flexibility, more compliance. But it also had to be really strong, because we're talking about landing a fairly heavy vehicle on a boat moving at sea.
Because we were having these problems during testing, we were even more worried about if we were to go over a whale with our vehicle and something went wrong, then the landing gear could snap, preventing us from retrieving the vehicle and possibly harming the whale in the process. When we heard about MarkForged, we realized that there was a way for us to 3D print new copies of our landing gear based on our existing design that was just as light but even stronger than what we were currently working with.
We've used other 3D printers in the past, and the good news is, like any 3D printer, you get the geometry you want, you get it put together pretty quick. The bad news is the type of a plastic it uses generally is good for certain things and terrible for others. With the MarkForged, we were able to change what kind of a fiber we put in the polymer, which let us change the characteristics of the part, which let us experiment with a huge variety of potential geometries, stiffnesses, forms that led us to a part that was unique to the vehicle and to the problem we had. We ended up going with a Kevlar composite built in the MarkForged because the Kevlar gave us the strength we needed for the shape, but at the same time it gave us the flexibility we needed to absorb the force of that impact. And since we got our design finished for that vehicle, we've never had a single landing gear failure.
Knowing that the MarkForged landing gear wasn't going to snap under the pressures that our quadcopter was dealing with, we felt much safer giving it to Ocean Alliance for them to send out to missions with real animals.